Good morning. I think everybody knows who I am, but Patrick Williams. I'm a software engineer here at Meta. I'm the team lead for the OpenBMC team here. This morning, I was kind of fed a little paragraph of what to talk about today, so kind of took that and ran with it here. But I titled it here "Opportunities for OpenBMC." So a little bit of agenda here. I'm not going to go through it. We'll get through it as we get through it. But you can kind of look at that up at the top here. First, start with the community update. So this is a quote we run into quite often on Discord and the mailing list is, "I'm using so-and-so's fork of OpenBMC," which seems to maybe be based on something from like 2.14, which if you go look is about 4 or 5 years old now. And then they have a question. So, usually that's a bug or is this feature supported or something along those lines. But with that statement, it's very clear that there is an interest for some parties to have releases of OpenBMC that they build things on. At Meta, we do not use releases. We deploy directly from master pretty much weekly. We make a build and push it out to our fleet. So you can do that. But if you're somebody like a chip vendor that's making an SDK or something along those lines, maybe you don't want to do that. There's some challenges with it. And so what we see in the community is that different companies kind of take some point in time as a starting point and then build on it and put it often in a fork out on GitHub, and then point their customers at it to leverage. So I think it's something that the community needs to do a better job solving, is how do we make a release of some sort and provide support for that in some meaningful way. So that's just some initial thoughts. So this morning, it probably has happened in the last couple seconds, I pushed out a tag of OpenBMC 3.0. So this is the next release of OpenBMC. The number means absolutely nothing. We're kind of taking the Linux approach that we got a big enough number that we rolled over. So it was 2.18 was the last one. But this is the last 1 year of upstream OpenBMC development. The basis for it, we always base on top of Yocto Linux. We're based on what's called the Rhinos release, which happened about a week ago. They also made a release, so they typically do their releases in April. And they've said that they will give long-term support of this until 2030. So this is a pretty strong basis from a Linux distribution standpoint of this is a stable basis where we'll get security updates and things like that for 4 years at least. Andrew Geisler and I recently added automated testing in Jenkins for this branch as well. So the same coverage that we get in master, we'll continue to get with this Rhinos branch. And I set up automation that every Thursday will pull all of the changes that Yocto has done, and they will put it into this branch so that we get all those security updates. So I guess, congratulations to everybody that has contributed something the last year. It's now in an official tag. I think because Meta does not use releases and a number of companies that build on top of OpenBMC do, this is where I'd like to see others in the community kind of step up and talk about how do we want to maintain a branch till 2030, if that's what we want to do, right? We get a bunch of stuff from Yocto for free that they're going to do for us, security updates of Linux. But all of the OpenBMC code is, what do we do with that? How do we get, fixes, if there's security fixes that come out in the next 4 years, how do we backport those onto this release? Are there features that we want to do that we want to backport, right? Those are kind of open questions that I'd look to others that care more about releases to hopefully step up and answer. So. All right, one of the phrases in my talking points was inflection points. So I was thinking back through some of my hobbies, and So, you think about technology, and it often has an S-curve shape to it. They talk about. So in 1994, a long time ago, Apple had something called the Quick Take 100. I don't know if anybody played with one of those, but when I was much younger, I got to play with one for a little bit. It had a 0.3 megapixel sensor. If you think about what are cell phones measured in today, right? And it had 1 megabyte of internal storage. You go forward 10 years though, and a digital SLR had easily an 8 megapixel sensor, multiple gigabytes of compact flash, and that was considered like entry level in 10 years later in 2004. And then on top of that, there was a whole software stack around it that had been open source, right? You had, I used GIMP and UF-RAW were the programs back then. I don't know even what's used today, but we basically in 10 years, the technology went from a curiosity to you could do everything you could do in film in digital. So looking at LLMs, right? That's the big hot thing. Where are we now? In 2017, I was working at a small internet bookstore that we decided to make a chip that its job was to basically look at pictures and decide if they had cats in them or not. So 2017, the big thing was ResNet. And then this paper came out that was attention is all you need. And that's kind of the foundational technology, right, of all the LLMs of where we're at today. So we are almost 10 years later from that. And so, I don't know I'm not going to predict when the S-curve is topped out, but somewhere between OpenClaw and Terminator is kind of the upper end of that, right? But I have experienced the last couple of years, right? And I think the last couple of years have been pretty intense in the amount of changes that we've seen in server design, especially. So I have a kind of a bold statement here that hardware technology is slowing. I don't mean this to say that some of our friends at chip companies are not getting faster chips. That's not what I'm saying at all. But what I am saying is that the last couple of years, there's been a lot of changes in systems infrastructure. We've had water cooling added to data centers. We've got rack power management. We've got huge dense backend networks that have been rolled out. We've got products from various vendors where they're co-developing CPUs and GPUs and server class products that we have to figure out how to integrate and do diagnostics on. And then a lot of big companies are making their own chips. So that's just a couple of the things that have happened in the last couple of years. When I look forward though, I don't see drastic changes like that coming, and maybe I'm just ignorant to it, right? But I think from what does a server look like? We've kind of gone through a lot of changes, and I don't see a lot of changes coming in the future. So when you talk about an inflection point, a lot of times people think of an inflection point as, it's going to go up and to the right very fast. But I think from a systems management perspective, we might actually be at an inflection point where things are slowing down. And that's good and bad, right? One thing that's good about it is it gives us a great opportunity to kind of come together and converge on stuff. There's been a lot of changes where people have gone off in various directions, and system integrators are left kind of trying to pick up the pieces and put them together and build a system around it. So, I think that, we've got an inflection point, an opportunity here to kind of come together, to collaborate, to consolidate, and build an open source systems management solution around OpenBMC. Right, I'll talk now about hyperscale systems management, right? Meta, obviously we're a very large deployment. So if any of you are a fan of early 2000s memes, you might know where this meme is coming from, but I heard you like to manage servers, so I put a BMC in your BMC, and now you really have to manage. So here's a picture of a system we've put into production now, but this was a picture I took last summer of it in pre-production. How many BMCs are in this picture? More than 72. There's a lot, right? So just some things that I can name off, whether they're actually running OpenBMC, whether they're actually a BMC, or there's something very similar to a BMC in a microcontroller format running its own operating system. There's a rack power manager. There are compute blades here, each that have inside them two BMCs, one to manage the server as a whole and one to manage some components inside the server. There's also network devices, both top of rack switch and backend switches that each have their own BMCs in them. And then sometimes they have an operating system on top of that that needs systems management that is controlling the switches themselves. Not to mention, a lot of those BMCs are talking to microcontrollers that do things like either diagnostics or security, or using PLDM and other technologies to manage the server. A lot of these now are vendor supplied from some of our chip vendor friends, and some of them are closed source. Many of them are built on open source technologies, right? But they're not in the same level of openness as OpenBMC as a whole. So this is definitely an opportunity. I didn't answer the question. I didn't count. Somebody said, well, let's see. There's probably around 100 at least independent ones. If you talk about different flavors of the BMC, there's probably around half a dozen to a dozen. Probably more than 100 per rack. Yeah. So this design is interesting. I think because it was a prototype, we couldn't fit it all in one rack, but it's actually all in one rack now, except for that big radiator thing on the side. That's a air-assisted cooling device. And that actually has a BMC-like device in it as well to control pumps and detect leaks and all kinds of stuff like that. So at a hyperscale level, when we look at a system like that, what are some of the challenges we have? One of them is cross BMC and cross BMC-like devices, right? So some of those microcontrollers. How do you identify errors? How do you isolate the errors? How do you take repair actions? Where maybe, for instance, one of the problems we constantly run into is that we have in our design, if there's a water leak, we shut off power to the servers, right? We don't want things shorting out. And so we find cases where the servers are not powering on, but the rack controller doesn't think there's any water leaks. And so why is that? Why are we powered off, right? And so you have to kind of aggregate signal from across multiple BMCs. In that design, you've got vendor-specific hardware diagnostic data where they've got tools that they can run either on their own BMC or on our BMC. If you know who the vendor is in that picture, don't think of their name because all of the hardware vendors are doing the same thing. So I'm not picking on whoever that picture is. But there's a lot of vendor-specific tools that are given that have to be integrated into the OpenBMC stack. There is their own hardware diagnostics, sometimes OEM data that comes out that if you really want support from them when the hardware's failing, you need to figure out how to get it to them. There's telemetry that's unique for their hardware. So things like sensors and metrics and those kind of things. Depending on the vendor, there's often limited source visibility. And from a meta perspective, potentially a lot slower fix deployment. Right? I mentioned we take upstream, we can make fixes on it, and we push it out to our fleet in a week. If you ask a vendor for a fix, how long are they going to take to qualify it? I can guarantee it's more than a week. And we talk about limited source visibility, and we talked about LLMs, right? A great thing of the LLM technology is that I can point my coding agent at a whole bunch of source code, and I can say, I have this problem. Can you point me out where you think it might be? And magically, a lot of times it points us at the right thing. Right? We've contributed fixes to things where we're seeing things in production, we're seeing problems in production, and we're able to just point our coding agent at it and say, have at it, and out pops a change that we'll fix up a little bit and contribute upstream. So, all right, this one, the title of this section is a little unique, but welcome to the ranch. So, what is the promise of open source software? Right, when you talk about software, there's the better, cheaper, faster, and usually people say pick two. But I think one of the promises of open source is that you can pick 3, right? You get all of them, hopefully, if we're doing it well. It's hopefully better, right? We're all working together on it, fixing bugs together. We're not beholden to an individual vendor to kind of fix what they have time to fix. Maybe it's cheaper, maybe it's not. I guess that's kind of a question of, is the license cheaper than your engineers that you have to support an open source product? But ideally, it's also faster, right? That we can turn around changes much faster than going to a vendor to supply our BMC code stack. We can get those changes integrated and roll them out without waiting for another company, right? We can find and fix problems and deploy them ourselves. I think looking at the OpenBMC community, I think we tend to be really good at the first one. I think our product, I think, is pretty solid. The OpenBMC stack is solid from a bugs and abilities. It's decent. Is it cheaper? Right. That's kind of is it cheaper to pay engineers, or is it cheaper to buy a license? That's up to you to decide. But definitely a challenge has been for us, I think, moving faster. I think a lot of times I hear complaints talking to various people of, oh, the open source community moves slow, right? And there's a lot of connotation around what do they mean by that. But that's something I think we could definitely improve on. One thing I hear from people is, why don't we just take whatever code people give, and just put it in the OpenBMC stack and say, here you go. Right. I had somebody that talked to me and said, as a proposal, how about if anything passes Jenkins, we just have a bot come and just say, here you go, merge it. And behind that thought, right, I think a lot of times companies have a thought that their code that they're giving to the open source community is a gift, right? That, hey, they put work into it and they're giving it out, and they did this great thing for you. I've got here on the screen, this is what I spent last month on coding agents. I don't know if anybody can add that number up. That is not millions. That is not hundreds of thousands. That is $25. And I do a lot of LLM-based coding, okay? So I'm not someone that is spending, $10 million on Claude, but, you can get a lot done pretty economically. And so, the gift is not the fact that you gave us a pile of code, right? The gift is, the fact that you tested that code, the fact that somebody reviewed that code, the fact that it fits the architecture of what all the other software everybody else is working on, right? The fact that you integrated it with the rest of the OpenBMC stack and added, end-to-end testing and systems management support through Redfish and things like that. And that it's developed in a way that we can maintain it, right? That as Yocto changes out from underneath us and GCC upgrades, we can easily fix whatever breaks with it. So as an OpenBMC maintainer, probably 50% of my time every day is spent reviewing other people's code. I know there's other people in the community that probably could say that they spend about that much time as well. So when people say, hey, the OpenBMC community just doesn't review things very fast, right? It's a time investment that, there are people that are spending a lot of their day reviewing the contributions that you make. But the primary responsibility, the role of one of those maintainers, I think is kind of, think of it like a farmer growing a herd of cattle. It's work. You've got to keep them healthy. You got to keep them fed, right? And there's some analogy here to all of the software, all these little components that we have to make a BMC work, right? They're very similar to these cows that we've got to keep fed and keep running. And there's times where we've made technical decisions and we've made what I'll call taste decisions, right? The maintainers, say, hey, we're not going to do this, we're going to do that, right? An example is, someone tried to contribute a bunch of code that was multi-threaded, and we said, we don't want multi-threaded code, right? And there's reasons behind it. There's some that's technical, there's some that's taste. But what's a real challenge for the community is when someone thinks that they have a bunch of code that is a gift, and they want us to start breeding llamas instead of cattle. right? They've got some unique thing that they developed internally that doesn't look like any of the other OpenBMC code, but they want the community to take it. And then when the community doesn't just take it with open arms, then it's, well, the community just is slow and doesn't want my stuff. Right? There's obviously more to it, right? And so that's what I want to communicate here. So some thoughts on how to help get involved. We definitely have a need within the OpenBMC community of additional developers, additional contributors, additional code reviewers. Right now, I looked this morning, there's 240 code contributions that have not been reviewed yet, that are just sitting there waiting for somebody to take a look at them. Other ways to help, all of these hardware vendors that I talked about that are doing their own thing, right? I think it would be great for them to go to standards bodies and say, hey, we did this thing with our chip or our system or whatever. How do we get that covered in the standards, right? And how do we get a reference implementation for it in OpenBMC? Instead of doing their own protocols and their own redfish extensions and things like that. Recommendation, if you are not a contributor or your team is not a contributor, is to start small, right? Don't just show up and say, hey, I want to do this big, huge thing, right? It's honestly not going to go anywhere. If no one knows you and you've never done anything in the community, it's not going to go anywhere. So you've got to start small. And that's what I encourage my team to do as well. When they're new to the team and they want to go do some OpenBMC stuff, right? We go give them some small things that are, either small fixes or, code maintenance improvements, code modernization, all that kind of stuff. So start with small bug fixes, start with small maintenance things. If you don't know what to do, reach out on Discord to one of the technical oversight members. Add some small components to Entity Manager, right? Just like do some small things to get your name there. Another area that when we talk about that standardization is coming together with design proposals. I'll take an example of a technology, SPDM, which is interesting from a security standpoint. We had 3 different companies, I think, come up independently with their own SPDM implementation, and then all try to come to the OpenBMC community and say, please take mine, right? And the difficulty there is, we don't want to pick favorites, right? And on top of that, they all cover different things, right? Is that, there's some pieces that are interesting to one company and some pieces that are interesting to another company. So instead of doing your own thing, if you say, hey, these are the pieces that are interesting to me, and somebody else can say, well, these are the pieces that are interesting to me, and there's some overlap and we can work together and we can get coverage on everything, right? It gets to that cheaper and faster piece of it that we're all looking for.